Hi everyone, in this video we're gonna look at operations or some operations on sets. And this is a recurring idea in mathematics. Often you have two elements of a certain set or you have two mathematical objects. And the question is, how can I make a third element or a third similar object from these two? And don't worry, this sounds a bit vague maybe, but you actually know what I'm referring to because you have some examples. If you work in the set Q, well, set of rational numbers, if I take two elements in Q, just pick two rational numbers, make it yourself easy, 1 and 2 for example, or even 1 and 1, well, there are two ways, or at least two ways, you can make a new rational element from these two. What you can do is you can just add them together. This is again a rational number, or you can multiply them with a dot or even without a dot, which is also a rational number. And we call actually plus, so addition and multiplication, we call them operations on Q. And we will see all the notations in the upcoming videos. We can already show you here because, for example, plus we can write this as, and I'm already gonna spoil some things here. Maybe you already know this as a function from the set Q times Q to Q, which sends the tuple AP just to A plus B. But this I will explain if it's already clear. Cool, you can probably skip a few videos. If not, don't worry, I will get to this. But here we're working on sets. So what I want to do is, if I take A and B sets, how can I make a third set out of this? Well, there are a few ways, and we're going to introduce again a lot of important notations, because these notations will be used throughout the next series as well, or at least some of them. What I can look at is I can take the union of both sets, A union B, and represent this with the accolades. Well, this is just all the elements X for which it holds that, well, either X is an element of A or X is an element of B. Well, you can also look at the intersection of A and B. So you can see that we're enlarging here the sets A and B. Here you're gonna look at or result in a smaller one because these are all elements X for which it holds that X is an element of A and X is an element of B. Just one difference, but it makes me get a different set. And we can also look at set difference. We can look at the set A minus B. These are all the x's in A, because we start from A, for which it holds that X is not an element of B. So of course you can also look at the set distance B minus A, and of course in general they are not equal. Question for you guys, can you come up with an example where A minus B equals B minus A? Think about it. Right. And as another exercise, if using some Venn diagrams, if I have the set A and I have the set B, well, I have four sets here, A union B, A intersection B, A minus B, and B minus A. Try to represent them on this Venn diagram. In the next video, we're gonna look at yet a different operation on sets, and this one will be key in our further understanding of